Let's start this second episode of London Futurists podcast with a prediction. After all, we are futurists and we should make predictions from time to time. So my prediction is about you, dear listener. It is that if you take the time to understand more about artificial intelligence, then you will be better placed to cope with many shocks and surprises that will take place in the next years and decades. It doesn't matter which line of work you're in, it doesn't matter what your hobbies are, what your age is. In all cases, your life will be changed in multiple ways by changes in AI in the times ahead. That's why Calum and I, as co-hosts of London Futurists, have decided we need to take this front and center. We need to talk about some of the things that AI can already do and some of the things it's likely to do soon. It's the technology that's going to have the biggest impact on so many areas. Calum, do you agree?
I do indeed. To take just one example, a lot of people, and I think rightly, say that in the next few years, next 5 years, say AI won't take all the jobs, but people who understand AI and can work with AI will probably take all the best jobs. And as we look further ahead, a lot of people think this is a pivotal century for humanity. Martin Rees talks about this a lot. I think this is absolutely true. And I think specifically this century, AI is likely to cause two events which it's not unreasonable to call singularities. A singularity being the biggest kind of change that can happen. It's based on the idea of singularities in maths and physics, where a singularity is a point at which a variable becomes infinite, and so everything changes. And I think those two singularities that we may see this century are the jobless economy, the technological unemployment, and superintelligence, also known as the technological singularity. And we'll cover those subjects much more in later episodes. We won't get too deep into those today. And David, I think you disagree about the economic singularity to some extent.
I'm not sure. I think it is sensible to think that people will lose their jobs to machines big time, even before machines are more capable than humans in every aspect. In other words, that there will be an economic singularity for many people before superintelligence arises. But I also think that people who are on top of things with AI will be able to keep their jobs until such time as AGI arrives. If you are, let's take a golf coach. Golf coaches who understand AI will take the jobs of golf coaches who don't understand AI, and they use AI in their business to help them coach people more effectively. Radiologists who understand and use AI will take the jobs of radiologists who don't understand and use AI well. But fairly soon, even the radiologists who are using AI will find that they can't get jobs at all, because AI will do everything better than the radiologists can do. And so there still will be some jobs until we reach AGI. That's one possibility.
And that might be what happens. Who knows? It seems to me that what almost everybody does in their job is only a subset of what they are as a thinking entity. And for many people, it's a pretty small subset of what they are as a thinking entity. And I think that most jobs will disappear, and I suspect this will be a bit like a phase change. It'll happen quite quickly. They will disappear when machines get to the point where they can do most jobs cheaper, better, and faster than humans. But I think that will still leave quite a long way for machines to go before they are fully human equivalent in all the ways that we think are important. But we don't know how it's going to work out. We have to keep an eye on things and plan for all the contingencies.
Well, we could talk about the kinds of human characteristics that some people feel are way beyond the abilities of any AI. So some people say that if the job involves compassion, or if the job involves creativity, or if the job involves common sense, the 3 C's, then their job will be safe. But I'm not so sure about that. I see examples of AI that shows some creativity, that appears to show some compassion, and common sense is a bit harder, but I think we're getting there as well. So I'm not sure that there will be areas of people's jobs that are safe from AI.
I think that's right. I think a lot of the jobs which involve compassion involve a display of compassion, which can be genuine in some cases. In other cases, it's professionally acted out, and machines can certainly do that. And creativity, will come back to creativity, I think, but there's no doubt machines are already creative. There's lots of ways in which they need to become more creative to get anywhere near human level, but they have already crossed the threshold into creativity.
Calum, you've talked about singularities happening in the future, but you've also talked about a big bang happening in the fairly recent past. Maybe you could bring us up to date on that.
That's right. 2012 is often said to have been the year of the Big Bang in AI. It's when a team of researchers led by Jeff Hinton figured out how to get machine learning to work in AI, machine learning being a branch of statistics, which goes back to about 1959. And the big difference before and after the Big Bang in AI was that before it, AI didn't make any money. It had done impressive things. An AI system built by IBM the year before had beaten the best humans at a TV quiz show called Jeopardy, which is a really impressive achievement. And well before that, another IBM system had beaten the world's best, probably best ever player of chess, Garry Kasparov. So AI had done some impressive things, but it didn't make money. After the Big Bang, after the arrival of machine learning, and in particular deep learning, and we'll talk about what they are, AI has made a great deal of money. And specifically, Google and Facebook have basically eaten the lunch of many mainstream media, which is one reason why they get a bad press, because the media don't like that very much.
I guess it's not just a commercial battle. Now that commercial companies see that via better AI, they are more likely to make huge amounts of money, I think there's a geopolitical competition as well, as different government agencies around the world contemplate with some dread the prospect that their enemies might have more sophisticated AI that could control their weapon systems, their cyber hacking, their malware distribution centers, and so on. So there's another kind of race there, which means that people are very keen to find improvements in AI in a way that probably didn't take place before 2012, when this machine learning stuff was often relegated as a fringe area, a niche interest, which only a few applications might be suited to.
Before we get too deep into the weeds, we probably ought to define what we mean by AI and also make some distinctions between it and consciousness and how it all relates to creativity. So artificial intelligence is obviously two words. The artificial bit is quite easy. It simply means an entity created by humans or possibly by aliens, but not by God or by evolution. The intelligence bit is a bit trickier because defining anything to do with the human brain is tricky. There's I think, a very good four-word definition of intelligence, which is goal-oriented learning behavior or goal-oriented adaptive behavior. So an entity is an AI if it was created by humans and if it learns and changes its behavior as it pursues a goal. There's a lot more you could say about that, but that's a good working definition.
I think that's a great definition. It's the ability to figure out in a general environment what needs to be done to achieve whatever goal is there. And the goal could be very general, whether it's winning in a game, whether it's working out the best route between two places on a map, whether it is working out which chemicals might have various properties when they are assembled. So there are goals, and intelligent software is able to figure out by looking at a whole bunch of data what the likely causes and effects are, what the patterns are, and is then also able to learn from more data as it updates its understanding. So this is the learning or the adaptive part. So I fully agree with that. And I would say that that's quite a separate thing from talking about consciousness. You can be very good at figuring out how to achieve your goals in a complex environment without having the kinds of inner sentience, the inner raw feels, which you and I and lots of animals seem to possess.
It's a very important distinction, I think, between intelligence and consciousness. They're both hard to define. Consciousness, we know what it is. We all experience it. It is the business of experiencing. It's what it's like to be you, is what consciousness is. And it does seem that intelligence and consciousness are entirely different, entirely orthogonal in the sense that you can have one without the other. You can have a high degree of one and a low degree of the other, and so on. So dogs, most people would agree, are conscious, and their intelligence is rudimentary. AIs are often highly intelligent, particularly in certain task-specific areas, but we've got pretty good reasons for believing they've got no consciousness whatsoever. And then there's a third element of creativity, and we should come back to that. I've said already that machines are already creative, but there's lots of different ways of being creative. I think a way into this is to talk a little bit about the Turing test and what it actually tests for. Alan Turing, one of the pioneers of computers, wrote a paper about the simulation game in which two contestants pretended to be a gender that they weren't, and a panel had to guess which one was the actual woman. And he suggested that a similar sort of test could be used to detect intelligence in an artificial intelligent entity. Now, I've always thought, and this is possibly a very ignorant idea, I think it's a controversial idea, that actually the Turing test wouldn't test for intelligence. It would test for consciousness. You wouldn't need a subjective panel like that to test for intelligence. You could simply look at the results of a process and see whether that was a highly intelligent entity which had produced the results. Whereas determining whether another entity is conscious or not, all we can do is talk to it and apply verbal tests to it to ascertain whether it's conscious or not. And that's how we figure out whether each other is conscious or not. David, do you take a more traditional view of the Turing test?
Well, I think the Turing test was an inspired thought experiment. It's not just about, is this piece of software intelligent in a particular area? Can it do some tasks well? But can it carry on a conversation on all the kinds of things that we humans like to talk about? So Turing talked about playing chess, but he also talked in his paper about discussing sonnets, discussing poetry, discussing Shakespeare, discussing music. And could the computer appear to the interrogator as having a sufficiently rich understanding of all these things that the interrogator couldn't be sure, oh, this is just a machine, and we know it's a machine because the responses are in some sense too robotic, too clunky. They lack imagination, they lack creativity, they lack sophistication. So I think it is a useful test, and more to the point, it's a good test for a very important area of software, which is customer support agents. We all are used to interacting sometimes with AIs on the phone or in chats and websites. Sometimes they can answer our initial questions, but then we humans who are seeking a better answer get frustrated and we want to blurt out, no, I want to speak to a human being now, please. You don't understand, you bot. But in the future, when these bots can pass the Turing tests, we won't have that frustration. We won't care that they're not humans. We'll be satisfied that they are able to conduct a very rich conversation with us. As for consciousness, I think the reasons I attribute consciousness to other humans is I think we have a sufficiently similar brain architecture. I don't know quite what it is about my brain that makes me conscious, but I'm willing to grant that my brain is sufficiently similar to lots of other people who seem to express themselves in broadly similar ways, which is why I am happy to say that humans and many animals have got consciousness, but I am reluctant to say that most AIs or any AIs today are conscious because I understand that they're put together in a very different way.
I want to quarrel with that because I don't think you think I'm conscious because you believe my brain architecture is the same as yours. You've never looked inside my head. You've never seen an MRI of my brain. You don't know what sort of architecture I've got going at all. I think you attribute consciousness to me because of the way I behave. The way I behave, it suggests to you that my thought processes are the same as yours. So it's an observational thing rather than a belief in the mechanism inside me, surely.
There could be an Android version of me that looked very similar to me but was made in a very different way, which was able to repeat many of the same kinds of things that I say. I think that would not be conscious, wouldn't necessarily be conscious. And I think it does depend to some extent on how the physics fits together. So I'm not sure.
But if this Android version of you, in conversation with you, its behavior was indistinguishable from another human's behavior, why would you deny it the label of conscious if it appeared in every possible way to be conscious?
We'll be right back after a quick break.
The People in Performance podcast offers insights into the strategic competencies, behaviors, and results needed to increase the performance of employees and leaders. The show looks at all areas of the world of work, including attraction and recruitment, onboarding, training, and succession planning. Tune in to get a better handle on the stages of workforce planning you need to master in order to guarantee long-term success in a rapidly changing world of work. New episodes drop each week. Check out the latest People and Performance episodes on your podcast platform of choice. Follow us on socials and read the latest articles at pppod.com.
We're in deep waters here. This is a great discussion. But the point you made earlier, Calum, is very important, which is that many of the conversations about intelligence, the opportunities from artificial intelligence, and, by the way, the risks to jobs, risks to social well-being, they don't depend on notions of consciousness. They depend simply on AIs being better at what you described, goal-oriented, adaptive behavior.
The other subject we need to cover off before we move on is creativity. As I said earlier, AIs have already demonstrated they can be creative, and a classic example was the famous move 37 in game 2 of AlphaGo's defeat of Lee Sedol in the Go competition. First time an AI beat a world-ranked Go player. It produced a move which apparently no human had thought of playing in the thousands of years that Go has been practiced by humans. That is surely a high level of creativity. Now, Demis Hassabis, the founder of DeepMind, the organization which created AlphaGo, talks about 3 buckets of creativity. There's interpolation, extrapolation, and entirely new stuff. So interpolation is taking a domain and taking one existing thing in that domain and drawing a line to another existing thing within that domain and finding a third point somewhere in between them. Extrapolation would be taking a point in a domain and then extrapolating it outside that domain, and that would be extrapolation. And then entirely new stuff he described as inventing the game of chess from zero. The AI would be told, design me a game which I can play in 4 hours, which I can describe the rules of in 10 or 15 minutes, but which I couldn't learn. It couldn't be a solved problem within a reasonably small number of lifetimes. So that would be an entirely new type of creativity. And he thinks that interpolation and extrapolation are already within the realms of possibility for AIs, and the entirely new stuff is outside their capability. And that seems like a pretty reasonable description of the state of play with creativity. But a lot of people say that AIs can't be creative, but it's simply not true. They already are.
Take music as an example. Maybe 20 years ago, one music AI professor, David Cope, was able to combine knowledge. He had software that could combine knowledge of all the pieces of music written by Johann Sebastian Bach and come up with a brand new piece, which audiences rated highly. And when they were given a musical Turing test, in other words, they were given 3 pieces of music, one written by Bach himself, but not very well known, so they wouldn't know it was written by Bach, one written by a human in the style of Bach, and then one written by the software in the style of Bach. The one the audience rated most highly and thought, wow, this is genuinely moving, was the artificial one. But you can say, well, it's just copying what's there already. So in terms of what Demis Hassabis was saying, this is more like interpolation, doing something new out of existing stuff. And I guess we're still waiting for when AI produces music which is beyond anything that humans have thought of. And when we listen to it, we'll think, well, that's so different, but still somehow we'll like it. I don't think we're that far away from that. I don't think there's anything mysterious about extrapolating. It may require more sophisticated modeling to create something new, but I think we should all be ready for it, and we shouldn't be too shocked when there are pieces of music or pieces of art or pieces of poetry which critics say this is outstanding.
I guess it has already happened in the visual arts where AIs, Google's Deep Dream, for instance, has come up with images which humans had not thought of creating. I think you're right in music. I certainly haven't heard any music which a human wouldn't have thought up. And that example of Move 37 in Game 2 of the Go challenge, I guess that was an extrapolation as well.
So how did we get here? Is AI just something that's been discussed in the last 10, 20 years or so? Calum, I think you've done quite a bit of research into the history.
It goes back a long way, the idea of it. It goes back certainly at least as far as the ancient Greeks. Hephaestus, that was his Greek name, the Romans knew him as Vulcan. He made automata. He made human-sized mechanical beings who wandered around and performed tasks for him. And Aristotle is believed to have said that if somebody, a god or a human, created machines which could carry out all the functions which humans can carry out, including slaves, that could be a problem because there wouldn't be enough things for the humans to do. So the concerns we have today were already around, being thought about with the ancient Greeks. Science fiction, of course, has played around with the idea of AI for a very long time. Arguably, the first work of science fiction was Mary Shelley's Frankenstein, and there's an artificial intelligence at the heart of that. Samuel Butler was possibly the first modern to write about technological unemployment. He wrote a book called Erewhon, which is Nowhere Backwards. That was a satire on Victorian England. It was a self-described utopia in which machines did all the jobs. And many writers, good and bad, have written about AI. E.M. Forster, a very good writer, produced an excellent, longish short story, perhaps a novella, in 1909 called The Machine Stops, in which the world is run by a massive AI with very interesting consequences. So the idea had been around for a very long time, but it came to fruition in the 1950s.
I guess as a result of the progress in the war, in which many countries were determined to crack each other's encryption codes, they were also determined to calculate trajectories of missiles more precisely. They wanted more accurate weather forecasts. After all, D-Day was highly dependent on reasonably accurate weather forecasts. And when people managed to put together systems that could duplicate some of these calculating tasks of humans, inevitably they started thinking, well, maybe once they get better, they will do more and more of what we humans can do. I understand there was a conference in Paris in 1951. It was all written up in French afterwards, which is one reason why most historians haven't paid too much attention to it. But it was perhaps the first major conference on what they called, in French, but I'll translate into English, computing machines and human thought, with a whole bunch of people there. And gradually people could see there was progress. At that conference in Paris, there was a demonstration of a chess-playing machine that wasn't very good at chess. It could only play with a king and a rook against a king, but it was remarkable. It actually moved the pieces by itself, and that was a sign that things were starting to move forwards.
There are probably two reasons why that conference in Paris in 1951 is not seen as being the official start of AI as a science. That official date is normally put at 1956, the Dartmouth Conference. And those two reasons why the Paris conference isn't seen as the official start, partly because it was in French, and English is, of course, the world scientific language. Apologies to France. And partly because of Norbert Wiener, who was one of the leading lights of the Paris conference and wasn't much liked by other people in the area. The Dartmouth conference was the brainchild of a man called John McCarthy, and it was held in 1956 in Dartmouth College in New Hampshire. And McCarthy actually defined what their subject was as artificial intelligence because he wanted to get away from the word that Wiener was using, which was cybernetics. So the field has got its name partly in opposition to Norbert Wiener. That Dartmouth conference was due to be a 2-month conference of about 10 people. In the end, it was probably about 6 weeks, and as many as 20 people attended it. Only 3 of them were there for all the sessions, but a whole lot of other people dropped in and out. They had very high ambitions for it. They thought that the field of AI could be a complete field, and human intelligence could be replicated within a few years. And not for the first time, expectations ran well ahead of what could actually be achieved. Some of the key figures from that meeting, as well as John McCarthy, were Marvin Minsky, Claude Shannon, Nathaniel Rochester, Herbert Simon, Alan Newell, quite a few others.
I think one reason it's interesting to look at the history is because if we understand what people thought and hoped for in the past, and we look at how their predictions fared, What were the factors that caused some predictions to come true more quickly, and what were the factors that caused other predictions to be delayed, often by decades? It puts us in a bit of a better situation to understand the scenarios possible for today. So if I look ahead a little bit from that Dartmouth conference, there was some work done by a different group of people who are more interested in modeling the human brain, the neural net architecture. So we've already said that in 2012, suddenly that field changed from being a bywater into being the hottest topic in artificial intelligence. Back in 1957, 1958, there was some work done with so-called perceptrons, which were able, by mimicking a very simple model of the human brain, to make some conclusions about some images. And it excited the New York Times reporter so much that he wrote a now infamous piece in 1958 predicting that we will soon have conscious beings, electronic brains, walking amongst us. So that was a disappointment. But another thing to learn from that is the reaction of some of the AI mainstream, like Marvin Minsky, like the educationalist Seymour Papert. When they saw that perceptrons weren't making much progress, they actually wrote a book, quite a famous book, that said that the whole field would never amount to anything. There were certain simple calculations that these neural networks were incapable of doing. Therefore, people should all concentrate their efforts instead on symbolic logic, or good old-fashioned AI, as it's now called. And that was a mistake. The argument in that book, which persuaded so many people, turned out to be flawed in many ways. It only looked at quite a simple network of neural architecture, and all the things that Papert and Minsky said were impossible could be done reasonably easily in due course by the time that better systems were designed, by the time that better hardware was available, by the time there was more data available to train these systems. So there's a lot to learn from there. We should beware the owners of a field of AI when they say, oh, there's only one way to do it, and it's such and such. And we should also realize that sometimes things are delayed for a long time before they suddenly move forward much more quickly again.
Yes, I forget who it was who said that, probably Arthur C. Clarke, he's usually the source of these quotes, who said that if an elderly but distinguished scientist said something is possible, he's almost certainly right, but if he says it's impossible, he's absolutely certainly wrong. And Marvin Minsky and Seymour Papert were right about the ability of perceptrons, given the technology available at the time. They could only be fairly simple, and they were very limited in what they could achieve. But once we got to the point where we had deep learning and lots of layers of what are analogous to perceptrons, and I'm sure we'll come back to that, much more becomes possible. So they were kind of right at the time, but wrong in the longer term.
To draw this to a conclusion for now, Calum, what's your thought on AI winters, and what's your thought on whether we might experience a new AI winter anytime soon?
We've had, I think, two major winters, and you have an interesting insight into the first one, which began in the early mid-1970s. And the characteristic of an AI winter is that researchers cannot get grants to do work in AI, and a lot of people decide that the field has overpromised and has hit a dead end, and there's no point continuing it. And then the second winter was in the late 1980s, didn't last very long. It was over pretty much by the early 1990s. But perhaps you'd like to talk about your friend James Lighthill.
James Lighthill was the person who wrote the infamous Lighthill report. He was a brilliant mathematician based for many years at Cambridge, and in about 1978, 1979, I thrilled to some of his lectures. I remember him throwing tin cans in the air and observing how they rotated in various ways and then modeling it all in mathematics. But he was the person, the very brilliant and perceptive person, who decided AI was not living up to its expectations, and that money which was currently being channeled into researching AI could be applied elsewhere. And as a result of that, many AI departments in universities around Britain were shut down.
And was that because of the combinatorial explosion problem?
I think they looked at what was predicted to happen, what the initial enthusiasts for AI had predicted. And he said, well, we're not getting there, are we?
Yeah. And then the field was revived, not least by the Japanese fifth generation computer project. And of course, it's slightly hard to remember these days, but back in the late 70s, Japan was the all-conquering industrial powerhouse of the world. And there was lots of lurid articles being written about how Japan was going to take over the world because its industrial companies were so efficient and so powerful. And they decided that they were going to push computing onto a whole new paradigm. And the rest of the world couldn't step by and let them do that on their own. So there was the ALVI project in Great Britain and a similar project in America. Investment came back into the field, and that carried on for a while until, again, results weren't really forthcoming. And by the end of the 80s, the second winter set in.
When I started work as a software engineer in the late 1980s, one of my bosses did talk about the Japanese fifth generation computing project and said we should learn about it because they may well succeed. And it turned out that Japanese companies succeeded in different ways, not with better AI, but with, for a while, the best mobile phone networks in the world. With the NTT Docomo and others, they developed the iMode application system well before there were applications on mobile phones in the West. The actual aspirations of that project were not fulfilled for decades later. But I don't see this as a conclusion that aspirations for AI will always fail. I see it again in terms of this timeline. Things are delayed until sufficient conditions are in place. Hardware has improved, there is sufficient data, there is improvements in clever software algorithms, and then things can develop much more quickly. And I think that's probably something, Calum, we should look at in the next episode. We should pick this up and discuss why it's unlikely that we're going to have another AI winter anytime soon.
Yeah, that would be a good way to start the next episode.
So until then, please watch out for London Futurist podcasts on all the good podcast hosts.
Bye for now.